Professor in the Department of Mechanical Engineering. I am here to discuss with you concepts of thermodynamics, right? So I think without delay we should start this topic, right? So as you can see that we are going to discuss concepts of thermodynamics, right? So moving further, right? So this word thermodynamics has originated from two Greek words, right? So what are those two Greek words? The very first word is thermi. Thermi means heat. Some people call it therm as well, right? And the other word is dynamis. Dynamis means power, right? So thermodynamics, if you divide thermodynamics in two halves, the one is thermo, other is dynamics. This thermo has come from the word thermi, which means heat, and this dynamics word has originated from the word dynamis, which is power, right? We all know that power is nothing but work per unit time. So rate of doing work is basically known as power, right? Okay. So from here we can go on defining the word thermodynamics. How would you define this word thermodynamics? Thermodynamics is nothing but a branch of science which deals with the energy interactions between the system and the surrounding and its effect on the properties of the system. Okay, slowly. Thermodynamics is a branch of science which deals with the energy interaction. Energy interaction in form of heat. As you can see that energy interaction in form of heat, right? Energy interaction in form of heat and energy interaction in form of work. So thermodynamics is a branch of science which deals with the energy interaction in form of heat and in form of work between the system and the surrounding, right? So two new words are there, system and surrounding. So we will take care of these words later on, right? So for now you need to understand that system is something about which you want to know, something which is under investigation, which you want to know about, right? That is your system. Sometimes you say that system is either a certain quantity of matter over which you are focusing upon, or it may be a region in the space about which you are focusing on or you are studying. So thermodynamics is a branch of science which deals with the study of interaction of energy in form of heat and work and its effect on the properties of the system. What do you mean by that? See, if you consider this room as a system, then suppose you want to study about the air of this room, right? So air of this room you need to consider as a system, right? When you supply certain amount of heat to the air of this room, what would happen then? Then the temperature or pressure or certain other properties, for example internal energy, will change, right, for this particular air. So the properties of the air in this room will start changing as you supply the heat. Similar is the case if you try to reject certain amount of heat from the air, then also the properties of this air will change. So this is what we are trying to say, that in thermodynamics, whenever there is an interaction of energy between system and surrounding in terms of heat or in terms of work, right, then the properties of the system, for example pressure, temperature, volume, these changes, right? Okay, so this might be clear to all of you, right? So now coming to the next slide. See, the word thermodynamics was very first time given by a scientist, Lord Kelvin, and Lord Kelvin given this word in 1849. Actually he introduced this word in a publication, right? Now the very first point tells us that thermodynamics is nothing but the energy interaction in form of heat and in form of work and its effect on the properties of the system. So I hope that I am clear to all of you that what does thermodynamics mean. So this is one of the definitions of thermodynamics. Of course, there are other ways to understand that, because this definition covers many of the aspects of thermodynamics, but still there are certain things which we can understand by some other definitions as well. So for that, now the second way of understanding thermodynamics is that thermodynamics is the branch of science which deals with the study of 3 E's. Which deals with the study of 3 E's. What do you mean by this 3 E's? The first E refers equilibrium. The first E refers is equilibrium. Specifically, if I say what does this equilibrium mean? Thermodynamic equilibrium. Okay. So whenever you will talk about thermodynamics, definitely your system needs to be in thermodynamic equilibrium, otherwise you will not be able to study that system, right? For that, your system must be in thermodynamic equilibrium. Now if I elaborate this word a little, means what is exactly thermodynamic equilibrium? So thermodynamic equilibrium comprise of 4 types of equilibrium. 4 types of equilibriums. Number one is thermal equilibrium, and number 2 is mechanical equilibrium, and number 3 is chemical equilibrium. If I write it down, first one is thermal equilibrium, and second one is mechanical equilibrium, and third one is chemical equilibrium, and fourth one is phase equilibrium. Phase equilibrium. What I am trying to tell you is that thermodynamic equilibrium basically comprises all these 4 equilibriums. If any of these 4 equilibriums has not been achieved by the system, then you cannot say that system is in thermodynamic equilibrium. So for the system to be in thermodynamic equilibrium, there is a need that it should be in all 4 type of equilibriums. So now we will understand one by one what is this thermal equilibrium. So thermal equilibrium basically tells us about the equality of temperature. Equality of temperature within the system as well as between system and surrounding. Because if temperature gradients will exist inside the system, then also the heat will start flow from one part of the system to the other part of the system. So it means that there should be a temperature equality between different locations of the systems, right? Another thing that we can understand is that the temperature of the system and the surrounding should be the same one, right? If the temperature is same for system and surrounding, then we can say that our system is in thermal equilibrium. What do you mean by this? Consider the air of this room as a system, right? When you supply some heat to the air in this room, what would happen? Temperature will start increasing, right? After some time, you see that the temperature of this room, right, is the same at every location, right? And what you see, the same temperature is also found outside this room. So then we can say that our system is in thermal equilibrium with the surrounding, because the temperature of this room and the surrounding, means outside the room, is same. So thermal equilibrium essentially means the temperature within the system as well as temperature between the surrounding and the system remains the same, right? Now coming to this mechanical equilibrium. How would you say that mechanical equilibrium is achieved by a system? If a system experiences unbalanced forces, then we can say that system is not in mechanical equilibrium. So for that, system should be undergone the forces which are 100% balanced, or simply you say that equality of pressure or pressure forces leads to a system to the mechanical equilibrium, right? The third is chemical equilibrium. What do you mean by chemical equilibrium? chemical equilibrium essentially means the chemical potential within the system or outside the system must be such that either no reaction is taking place, or even if the reaction is taking place, the basically rate of reaction in forward and backward direction must be the same so as to maintain the chemical equilibrium, right. Now coming to the next part, which is phase equilibrium. Now phase equilibrium means during the analysis of the system, right, your phase must be constant. It may be a two phase system or one phase system, but the phase must be constant, right. So if you are able to achieve all these four type of equilibriums, then only you can say that our system is in thermodynamic equilibrium. In which equilibrium? Thermodynamic equilibrium. So why I am emphasizing on this word equilibrium so much? Because if your system is not in thermodynamic equilibrium, you will not be able to define the state of the system. You will not able to actually analyze the system. So your whole purpose that you want to know something about the system, technically there are certain parameters about which you want to know, you will not be able to know if the system is not in equilibrium, right. So the whole thermodynamics revolves around this word equilibrium, specifically thermodynamic equilibrium. Now if I come to the second word, that is energy, what do you mean by this word energy? See, in thermodynamics, as I said, either you deal with heat, which is energy, or you deal with work interactions, heat interactions or work interactions between the system and surrounding. So this is what? Nothing but heat. This is also heat, right. Even if you talk about entropy, is nothing but a form of heat, right. Energy itself, energy, so I was talking about that heat is nothing but energy, work is nothing but energy, entropy is nothing but energy, right. So all these three terms, not only these, but even if you talk about enthalpy or some internal energy, whatever you are talking about, it is just energy. So whole thermodynamics revolves around the energy interactions. So that's why you say that thermodynamics is a science which deals with the study of three E's. From one of these three E's is energy. So that's why the energy plays a vital role in thermodynamics, because in whole thermodynamics you are talking about nothing but energy interactions, right. You are trying to extract some utilizable form of energy from a system. So again, as I told you, energy is involved everywhere. Now if I come to this term entropy, what is this? See, entropy I would define right now, okay, but for your probable understanding I will try to define right now, but it is a term that would I will explain this term later on in detail, right. So entropy in general tells about, it is basically the measurement of randomness of the molecules of any system, right. But if I talk about the essence of entropy, why do we actually study entropy, then what is that? See, if you want to know whether a system or a device can be made or not, how would you come to know the fact whether you can make something or not? This entropy can tell you, or entropy change can tell you rather, that whether a device is even possible to make or not. Entropy change can tell you whether a process would be spontaneous or not. Entropy change can tell you the limit of devices as well. For example, you have made a device, you want to know that what maximum efficiency of this device is possible. It means that to what extent you can extend the limits of these devices, particular device, right, that can be understood with the help of nothing but entropy. So entropy is just because of the losses, energy losses associated with the system or the surrounding, right. So that's why this term becomes important, right, because if you know the change in entropy of a system, you would definitely able to know or find out that how much utilizable work can be extracted from certain system if you know about the entropy or the concept of entropy. So I will discuss about the entropy in the coming lectures later on, right? But I have given you a brief introduction about this term entropy. Now, coming to the next point, what is thermodynamics, right? Coming to the next point, what is thermodynamics? See, the next definition of thermodynamics is that it is again a branch of science in which you convert disordered or disorganized, rather say disorganized, disorganized form of energy into organized form of energy. See, disorganized form of energy into organized form of energy. What do you mean by this? What do you mean by disorganized form of energy? See, heat is disorganized form of energy. Why we are saying so? Disorganized form of energy. Organized form means something that you can utilize. Organized form means something that you are utilizing even. For example, work which you are utilizing, or in actual practice you are using that. There is a purpose which is being fulfilled by the work, but not by the heat. Okay, for your understanding, I will say, see, heat is a low grade energy. Why so? Suppose if I compare that you are, suppose if I take an example that you are living in Delhi, right, and you have taken one Bisleri bottle, right, and you have to drink that Bisleri bottle, and I ask you to drink, suppose you do not have that Bisleri bottle, then I ask you to drink that tap water. So in which case, if you drink tap water or you take that Bisleri water, then in which case do you think that you will be more healthy, right? So if you intake the mineral water, that would be more beneficial to your health. You won't get sick probably. But if you intake polluted tap water, then obviously you will get sick. So I have given this example just to understand that which water do you think is more valuable or more utilizable or more useful, rather you say. So that mineral water is definitely having more value than the tap water, right? So this is what I am trying to tell you, that heat is something like tap water. That is not that much useful. You can make it useful with the help of certain machineries, right? You can extract those polluted material from that particular water, and then you can make it useful, right? Similarly, the heat is unorganized form of energy, means the molecules are randomly moving from one place to the other. They are moving here and there, but there is no resultant displacement of the molecules which can be utilized or extracted, right? So for that, what you need to do, so to utilize the energy of the heat, what you do? You give that heat to a device which is known as heat engine. You give that heat to the device which is known as heat engine, and heat engine will do that work which was done by that mineral device, by the device which was converting tap water into the mineral water. Similarly, the heat engine will do what? It will basically orient the molecules to move in a unique direction or in a single direction, so as to get an resultant effect in terms of pressure. For example, you take an example of that piston cylinder arrangement, right? What happens there actually? So there is a charge inside, air plus fuel mixture. You basically spark, means give some heat to that charge, and then again the more amount of heat generated over there, right? And what happens, since that whole gas is enclosed in a cylinder walls, right? And then upper part is basically you can say the piston is there in upper part. So what happens, that molecules will try to go and strike to the walls of the cylinder, but since they are rigid, they won't go anywhere, right? But when these molecules will strike to the piston, piston is free to move, so piston will start moving up. If the force applied by these molecules is enough to encounter the weight of the piston, then definitely piston will start moving up. So are you getting my point? Means what you have done, you have converted the random motion of these molecules into an ordered motion, or basically a directional motion, right? So piston motion is basically a directional motion, reciprocating motion, which you can utilize and later on convert this into the rotational motion with the help of which mechanism? Slider crank mechanism that you study in theory of machine, that to convert this reciprocating motion into the rotational motion you use slider crank mechanism, and with the help of that you convert this reciprocating motion of the piston into the rotary motion of the crank, and then this rotary motion of the crank later on sent to the axle, which later on sent that rotational motion to the wheel, and this is how your automobile comes into action, or basically you can say starts moving. So now you gave some heat, but your automobile is moving, means you have given some disorganized form of energy to the system, and that system has converted the energy into the organized form, means which is something useful to you, because your automobiles you use in daily life, there are many essential uses of those automobiles. As we know that if you transport from something from one place to the other, you use that, or for the passenger service you can also use all those devices, right? So what I'm trying to say is that heat is nothing but a disorganized form of energy, and work is nothing but the organized form of energy. I hope all of you are clear with all these definitions of thermodynamics. Now coming to the next slide, see, this is some broad definition of thermodynamics. What I am trying to say is all that what I have told you right now can be covered in this definition at once, right? Now thermodynamics is a fundamental subject. I am trying to explain this definition now. So thermodynamics is a fundamental subject which describes the basic laws governing the occurrence of physical processes. What do you mean by this? Governing the occurrence of physical processes. See, there are n number of physical processes happening in this world, right? There are certain processes you want them to happen, or there are certain processes which are happening naturally, spontaneously. For example, we know that the water falls from higher elevation to the lower elevation. That is a spontaneous process. For example, you know that you grow older, your hair grows what? Gray. So that is the example of spontaneous process. For example, you take a cup of coffee and you put that coffee in some open space, and this coffee will definitely get colder in some time. So what is happening? That heat is being transferred from the coffee to the surrounding, or basically you can say that process, the direction of the process is spontaneous, because you have not added any system to happen that process, because it is happening automatically. So that is a spontaneous process, right? But why this process is taking place in this direction only, why it is so, is governed with the help of the basic principles and laws of thermodynamics. That tells you that why this process is happening only this way. Like why heat flows from high temperature to low temperature only, and what happens to the entropy when it happens, right? So all these things are taken care in a subject called thermodynamics, right? There are certain processes which you cause them to happen. For example, you take an example of refrigerator. What you do? See, refrigerator maintains a temperature which is lower than the surrounding at particular space, which you generally call evaporator, right? So inside evaporator, the temperature which you are trying to maintain, which is lower than the surrounding, right? What is happening? You are extracting heat from the evaporator to the surrounding. See, temperature of the evaporator is low and temperature of the surrounding is high. But what you are doing? You are extracting heat from low temperature and rejecting it to the high temperature. So this process is not spontaneous, because this process cannot take place automatically. You need to add some device which is known as refrigerator in this case. What we are doing to run that device, we need to give certain amount of work which we give in form of electricity in case of refrigerator. so that that refrigerator can convert that, basically can transfer that amount of heat, that which is known as refrigeration effect, and transferred to the surrounding, right? So now, so this process is automatic, spontaneous, or you are causing that process to happen? You are causing that process. So whether the process is spontaneous or not spontaneous, which is, or you can say non-spontaneous, in both the cases there are certain laws to be followed in thermodynamics, right? There are certain laws to be followed which are explained by thermodynamics. I hope all of you are clear by this point, right? Now, when these processes happen, what happens? There is a transfer of energy or transformation of energy. See, in case of refrigerator, what was happening? You are transferring heat, which is energy, from refrigerator to the surrounding, or from evaporator to the surrounding. In case of coffee example also, what was happening? It was a spontaneous process, but heat was being carried out from the coffee, not carried out, it was basically automatically coming out from coffee because of temperature difference. This is general law of, so you will understand that which law is this actually, right? In second law you will understand that why exactly it happens, or why we need to use a device, because a clauses statement is there in second law of thermodynamics, which says that it is impossible to construct a device which basically can transfer the heat from low temperature to high temperature without consuming any work. So this was the law. So later on I will discuss all these things in detail, but for time being I think I should associate it with this definition only. So for that, the transfer of energy takes place whenever there is the occurrence of the physical process, and because of this transfer of energy, what happens? There is the effect on the properties of the system. See, if energy is being transferred either into the system or coming out of the system, what happens? The properties of the system changes, either pressure, temperature, volume, all these properties starts changing, right? So this is the basically broad definition of thermodynamics. Now coming to the next slide, see, there are certain applications of thermodynamics, right? So I will start with this slide only. Now see the first definition that thermodynamics tells about, number one, feasibility of a process. As I told you earlier, that thermodynamics is that subject which tells us whether a process will happen or not. So there are many other subjects which guides different principles, which makes us understand, okay, these are the physical processes, right? And we need to follow these laws given by some other subjects to understand those physical processes. But what is the difference between the laws given by other subjects and the laws given by thermodynamics? The basic difference is that feasibility of a process, whether a process is possible or not, whether a device can be made or not, this can be told only by thermodynamics. There is no other subject that can tell you, or that can guide those principles which can tell you that whether a device or a process is possible or not. I hope you are getting my point, right? Even if a process is possible, then to what extent it is possible? Then to what extent that process is possible? And even that process, if we know, okay, this process is possible to certain extent, but in which direction this process is possible? Whether this process is possible all the directions, or there are certain directions in which this process cannot happen. Or if you want that process to happen in particular direction, what you need to do? So answer of all these questions are given by thermodynamics. So I am trying to tell you the essence of thermodynamics, that why it is widely used everywhere and why it is of prime importance, right? So now, in which direction the process is feasible, I have already explained to you. Now the second point, if I talk about this second point, thermodynamics tells us about certain things which we cannot do. That is very important. Why? See, there are n number of things which we can do in a short period of time of lifespan, whatever we have, we can do n number of things. But if we try to put our efforts in something which is impossible to do, you will be wasting your whole life doing something which is impossible. For example, suppose there is a scientist who is trying to make an engine of 100% efficiency, and we know by the laws of thermodynamics that even in an ideal case you cannot make such engine. If you cannot make an engine which is having 100% efficiency, why are you wasting your efforts, or why are putting your whole efforts making such an engine which is impossible, right? So if you know that, you won't be wasting your time. So that is what of prime importance, that something which you cannot do is basically guided or explained or understood with the help of thermodynamics. Now the third point, the thermodynamics tells about the directional constraints imposed over the processes. I have already explained whether a process will take place in this direction or in other direction or in all direction or in which direction, or when it is taking place, what are the constraints imposed upon the occurrence of that particular process, can be understood with the help of subject which is known as thermodynamics, right? Now whether the process is happening spontaneously or the process we are occurring that process, in both the cases what happens, in both the cases thermodynamics tells you that what are those directional constraints which are imposed on spontaneous processes or the processes. For example, a cup of coffee, I have already explained you that example. So in that case, if you want to know what are the constraints, in which direction, or why the heat is being coming out of the coffee only, why it is not going, or why coffee is not getting hotter, so all these things can be explained with the help of thermodynamics only. Now coming to the last point of this slide, see, when all these process happens, there is a relationship that we need to establish. There is a relationship between the properties that we need to establish so that we can understand or we can calculate the properties whenever we have been given certain properties of the system. What do you mean by that? See, suppose I want to analyze the air inside this room. I want to know certain properties of the air inside this room. I have been given certain properties. For example, I have given 2 properties and I need to know other 5 properties. What you need to know? You need to know the relation between these given properties and the properties which you need to find. So which subject basically gives those relations between those properties, and that is thermodynamics. So thermodynamics establishes the relationship between the properties of particular system when the process takes place, right? Now coming to the next slide, application of thermodynamics. See, all of you know that power plants are widely used to generate electricity, right? So if you want to know how the power plant works, you need to know thermodynamics. The devices which are used in power plants, for example, a boiler to generate the steam, and that steam goes to turbine where expansion takes place, work is extracted from the turbine, that steam goes to later on condenser where this steam is converted into saturated liquid, later on goes to pump, pressure is increased and sent to again boiler. So all these processes are understood with the help of thermodynamics only. So that is the operational part. So if you want to understand how a power plant works, you need to have knowledge of thermodynamics. If you want to analyze different systems which are working inside thermal power plant, you need to have knowledge of thermodynamics. Suppose if you have to design certain device, then there are certain limitations, thermodynamic limitations that you need to know. So thermodynamics is all around the power plant. Even if you are designing a device or you are analyzing a device or you are optimizing the efficiency of a device, you need to have knowledge of thermodynamics. You need to have knowledge of principles and different guidelines given by the thermodynamics, how to analyze a system, even how to define a system, right? So even if you design or operate the power plant, you need to have knowledge of thermodynamics. If you want to understand how the steam, gas or there are other fluids, how they behaves when they interact with certain devices. For example, steam when comes in contact with the turbine blades, how does it behave? You know, what pressure of steam is required, right? How would you generate that pressure? What are the other hidden properties of the steam which will change when you increase the pressure or temperature of the steam? So all these things can be understood with the help of thermodynamics, If you have to increase the efficiency of thermodynamics or efficiency of power plant, that also can be done with the help of thermodynamics. Now coming to the refrigeration and air conditioning part. All of you use either refrigerator or air conditioners or both. Probably both of these devices you might be useful, you might be aware of both of these devices. Now in case of refrigerator, think exactly what happens. That refrigerant goes to the compressor, compressed, then sent to the condenser, heat is being rejected, converted into saturated liquid, and then it comes to the expander, which is throttling valve, and then this basically two-phase mixture basically goes to evaporator where heat is being extracted and then again goes to the compressor. So this is basically probably the cycle of either you call this air conditioner or you call refrigerator. So if you need to understand, if you have to design refrigerator, you need to have knowledge of thermodynamics. If you have to analyze the refrigerator or air conditioner, you need to have knowledge of thermodynamics, of course. So in designing and analyzing, as well as if you have to understand how your refrigerant behaves when it comes in contact with certain devices or it is flowing in particular thermodynamic cycle, then how does it work? So all these things can be explained with the help of thermodynamics. Now if you have made a refrigerator, but now the challenge is you have to optimize the efficiency. So there are certain ways to optimize the efficiency. So all these things of course can be done with the help of thermodynamics. Now coming to the next application of thermodynamics is basically the combustion chamber. You probably might have encountered with the internal combustion engine devices like your 4-wheelers, 2-wheelers, all these vehicles are having internal combustion engines. Either they are 4-stroke or 2-stroke, in general they are 4-stroke engines, or petrol engine or diesel engine. So all these engines, what are they doing exactly? So there is a, for example, 4-stroke petrol engine, you take an example of that. So some charge, air fuel mixture coming in through the inlet valve, and that charge is now compressed with the help of piston, and then after when the compressed piston reaches to TDC, when the compression at the highest level, or you can say it is compressed probably whatever the compression pressure required, till that pressure if you have suppose compressed, then you add some heat or basically you spark, and through that spark that charge starts burning, and once the charge burns, it produces enormous amount of heat and propels the piston downward, or basically there is an impact pressure which propels the piston downward. So this reciprocating motion of the piston, as I earlier told you, converts into the basically rotary motion of the crank with the help of that connecting rod, and then that motion is transferred to the wheel with the help of axle later on, right? So if you want to understand the thermodynamic aspect of this, for example, suppose you need to calculate thermodynamic efficiency, you need to have knowledge of thermodynamics. Without that you cannot do. So this is basically pure application. The earlier one also, these are the pure applications of thermodynamics. So you need to design the system. Suppose you need to design an engine, you need to have knowledge of thermodynamics. you need to analyze that internal combustion engines, then also you need what? Thermodynamics. Similarly, if you want to understand that how the fuel air mixtures behaves, then also you need to know thermodynamics. Suppose if you want to optimize the efficiency of engine, means an engine is available but you need to increase the efficiency of that engine, you need thermodynamics. Now coming to the next application, which is renewable energy systems, though there are n number of renewable energy systems, but I will be talking about wind turbines and the solar plants, solar panels. So solar panels and wind turbine, both of these devices are renewable energy systems, and if you need to analyze these devices or optimize the efficiency of these devices, or you have to design these devices, you definitely require knowledge of thermodynamics, or simply you know that you definitely require the principles which are basically guided by the thermodynamics, right? So coming to the next slide, other application is material science, means where in material science also you may have to design some materials which can withstand very high pressure and temperatures. What are the applications of such materials? The application of such materials is jet engine and nuclear reactors. So in these two applications, not the two applications, but I have explained only two applications. There are n number of applications you can encounter. So these jet engine and nuclear reactors, these are two applications where you can see that if you need to design, suppose jet engine or the nuclear reactor, or if you have to analyze, or if you have to increase the efficiency of these, then also you need thermodynamics. But if you need to understand that what materials should I use so that it can basically withstand high pressure or high temperature, that can be guided with the help of thermodynamics. Which material should I use? Or even if I am making a material for such applications, what are the guidelines, what are the principles that I should follow so as end up with making such material which can be used in jet engines or nuclear reactors. Are you getting my point? So if you are making or designing some basically some material, then also you need thermodynamics. So there are n number of applications, but I have explained few applications of thermodynamics. Okay, now I will recommend certain reference books for the thermodynamics, right? What are those reference books? The very first book which I will recommend, which is Thermodynamics, an Engineering Approach, SI Units by Sanjol and Bowles of McGraw and Hill publication, right? So I have actually mentioned these books in particular order, or you can say the first you need to follow this book if you haven't studied thermodynamics before. So you need to follow this book, and suppose if you have already gone through thermodynamics, you are clear with your basics, then you can follow the Principles of Engineering Thermodynamics SI version by Mawana and Shapiro of Wiley publication, right? And if you have already gone through these two books, then you can go for Fundamentals of Thermodynamics of SI version by Wozniak and Sontag of Wiley publication, right? Now next book which you might have heard already, which is an Indian author book, Engineering Thermodynamics by P.K. Nag, McGraw and Hill. So this book is also good, but I will prefer that you need to use this book, specifically this P.K. Nag book, for numericals. So I think that would be beneficial to you if you use this book for numerical point of view. Rest other books you can use for making your concepts. For example, this book I will prefer if you haven't studied thermodynamics by now, because it explains things in a very easy manner, right? and Moran and Shapiro is quite good for specifically for the second law of thermodynamics, specifically that availability aspect, right. So I think for today we will call it off, because we are done with all these prime introduction with thermodynamics. Now we will start with very simple definitions in the coming lectures, like system, surrounding, and universe, and many other state, point function, path function, and you might have heard all these words in your school level. So I will be discussing all those topics in the coming lecture very soon. So thank you for listening me quite patiently. Thank you everyone. Okay, hopefully we will see you next. Okay.